What is entropy? Entropy is one of the concepts that is a bit hard to understand, and in the same way it is a bit hard to explain. In this video I'm going to explain the concept of entropy in a very simple way. So let's go ahead. There are some quantities that are sensible. It means that you have physical sense of them. For example, temperature, heat. When the temperature is high, when it is low, and when we have a high heat, low heat, when it is cold, when it is hot. And these quantities are measurable. It means that you can measure these quantities directly or indirectly. The entropy is somehow related to the concept of Gibbs free energy. The Gibbs free energy, we use this quantity when we want to know which state of a system or material is stable. The stability of a system or a material in its different states is dependent on temperature, on pressure, on composition, and so on. All these parameters are related somehow to the Gibbs free energy. For example, in the process of solidification, when you solidify a melt, the temperature is below the melting temperature, and below the melting temperature, the Gibbs free energy of the solid state is lower than the Gibbs free energy of the liquid state. So the solid state is more stable because the Gibbs free energy of it is lower below the melting temperature. Above the melting temperature, for example, you consider these ice cubes. Above the melting temperature, the Gibbs free energy of the liquid is lower than the Gibbs free energy of the solid. This Gibbs free energy is obtained by this equation. It is equal to H minus T multiplied by S. H is the enthalpy, and this enthalpy is related to the energy inside the material, the vibration energy, the transformational energy, and it is also dependent on the volume and the pressure of them that we have in our system. It is somehow sensible, like temperature, and we can measure enthalpy somehow indirectly. T is temperature, which I explained, and S is entropy. How entropy is measured and how it affects the stable state of a system. This equation tells us that when entropy is high, the free energy becomes low, and it means that it makes the system more stable. But how this happens and how entropy is raised or how entropy is reduced? Another example is purification of the materials. Imagine pure copper that we use for pots. This copper has a purity of about 99%. But when we want to use this copper as wire for electrical conductivity, the purity of this copper should be higher, for example, 99.9% or even higher, 99.99%. And the purer this copper becomes, the more expensive it will become. It means that when you want to extract the impurities from this copper, you have to spend some energy and pay more for that. But why this happens? It is somehow related to the entropy of the materials. To explain you entropy that is somehow sensible and you can understand it, I give you an example of a tidy room. When you make your room organized, After a while, you will notice that your room becomes untidier. But when your room is untidy, the reverse condition never happens. It means that an untidy room will never become a tidy room if we don't do anything to make it organized. But for the reverse situation always occurs. But why this happens? It is somehow related to the concept of the entropy. I give you another example. Imagine that you have a bundle of white ping pong balls and black balls. And you have separated these balls inside a bag. When you stir a bag and when you allow some movement of the balls inside a bag, you will notice that these balls are mixed. But when you have this bag of mixed balls and when you stir them, the reverse situation will never happen. We never have this. We always have this. We have this only if we open the bag and rearrange the balls by our hand. It means that if we only spend some energy to rearrange those balls. But this condition, this situation, always happens when we stir the bag without spending energy. But why this happens? It is related to the number of states that we have in each condition. In this state, we have only one state that we can separate the balls. But in this state, we have a lot of states that you can mix the white and black balls. So here we say that we have a higher entropy. It means that we have higher states that we can mix the balls. Here we have only one state. The entropy of this state is higher than this one. S2 is higher than S1. The interesting thing is that we can never measure the exact value of entropy. We can always calculate the change of the entropy. For example, how entropy changes when we have the conversion of state 1 to state 2. But the exact values of the entropies, we cannot calculate them. So the important thing about the entropy is the difference in the entropy and not the exact value of the entropy. So now we can understand why the purer metals are much more expensive than the metals that have some impurities. For example, about copper, when you want to buy a pure copper with this impurity, you have to pay much more than the copper with this purity. I don't know the exact cost of these coppers, but I know that the difference is high. In a pure metal, for example, you consider that you have only the red atoms. We have one state that we can arrange these atoms in the crystal structure. But when you add only one blue atom into this structure, the number of states that you can have will become much more than one. You can calculate it. When you add two blue atoms, you will even have much more states. And the much more blue atoms that you have, the much more states you will have in your system. So it means that the entropy in this state is higher because the number of states that you can have is higher than this state. So here I have S2 bigger than S1. So when the entropy becomes higher, when the number of states in the system becomes higher, it directly affects the free energy of the system. For example, in state 2, we have H minus T multiplied by S2. We have also a change of enthalpy, and in some cases, we should consider this change in enthalpy. But let's suppose that the change of entropy is not so much high. It doesn't affect the Gibbs free energy, which is true in several states. In this state, in state 2, in comparison to state 1, the value of the Gibbs free energy in state 2 is lower than state 1. So when you have metals with some impurities, because of the role of this entropy, the value of its Gibbs free energy is lower than the pure metal because of this entropy. And that is why when you want to make a metal purer, you should spend some energy and you should pay more for that purer metal. And in nature, almost all the time, you will have the metals in their impure states. We rarely can find metals in pure states in the nature because the amount of the value of its Gibbs free energy in the pure states is much higher. Thank you for attention, and don't forget to like if you found this video useful.